So this problem comes from the MyLab math, and it says radioactive uranium-235 has a half-life of about 700 million years. Suppose you find a rock and chemical analysis that tells you only 1/16 of the rock's original uranium-235 remains. How old is the rock? So to take a look at this problem, let's check out our formula sheet and see what we have that involves half-life. So here's the formula sheet, and this is an exponential model. And here is our half-life formula on the right-hand side of this table. So let's kind of take a look at this formula and take a look at this problem. So I'm going to write the formula on the board here. And so when we discuss this formula and we're looking at the different parts of it, this is the future amount, what remains. This would be the starting amount. And then we've got a lowercase t, which stands for the time. And we've got a capital T, which stands for the halving time or the half-life. So in this problem, this is different than the typical problem we see with half-life. It tells us that the half-life of this uranium-235 is 700 million years. So this would be my capital T in regards to this formula. Suppose you find a rock in chemical analysis that tells you 1/16 of the rock's original remains. How old is the rock? So it doesn't tell us the starting amount. It doesn't tell us the future amount. But it tells us that the fraction 1/16 remains. So that fraction is going to refer to the future amount divided by the starting amount. If you started with, let's kind of put this problem aside. Let's say you started with 100 grams of something, and then it has decayed, and after some halving time, and it went down to 40. So the ratio of what remains would be 40 over 100, or 4/10, or 2/5 when I simplify. So it's the same thing here, but they tell you that fraction. So it's the 1/16. So it's like you took and divided both sides by the starting amount. So 1/16 remains. And then you have 0.5 raised to the t over capital T, and capital T is 700 million. Now I'm going to keep the 700, just 700, but I know that 700 million would be 700 with 6 zeros attached to it. So this is 700 million. Or I can use this units with the 700. So now the question is, what goes in this place? And so we have some values. We have some values because this is a multiple choice question. Now, in order to solve something for an exponent, we have to know some algebra that involves logarithms. And so we have not explored logarithms, and this is not an algebra class. So instead, what we're going to do is take a look at the answers they give us and see which one makes the most sense. And you can also try them and see what fractional exponent would give you 1/16. So now I'll show you how to do that on the calculator. I'm just going to write out some of the values they give me. Now, when I say million, I know that the units of million here, if I'm using million as these units, I have to use million as those units too. So I can leave it as 350, I can leave it as 175, but when I put in this one, I have to say 2,100 million instead of billion. And so all of these in the multiple choice are billion. So now let's grab the calculator and see what we can do. So I'm going to just put it off to the side. And the first thing I want to do is see what decimal 1/16 is. So it's 0.0625. And then I'm going to put the right-hand side, and I'm going to see what exponent makes it match. Now, if your calculator uses a caret symbol, make sure you surround the exponent with parentheses. If it superscripts like this, then you don't have to surround it with parentheses. But I'm going to try the first one. 350 million divided by 700. And what do I get here? I get 0.7. Well, that's way larger than this. So I think that the millions are probably not going to work. Let's try the next one. Now, instead of retyping this, what I can do is hit second enter, and it pulls down my entry, and I can just change this. So 2,100 million. Remember, the units here are millions on the, and if you want to, you can write out all the zeros, but it gets a little complicated. Now, because I have an extra digit here, I need to hit second insert and insert that 0, or I need to type out the exponent again. So now when I try 2.1, I'm getting close. I'm closer, right? 0.125 is way closer than this. So I'm going to exclude some of them. So this one I'm going to exclude. This one is too small. We saw that this doesn't work, but it's somewhere around this. So let's try, this is smaller than 2.1 billion, so that's going to be out. So let's try one of these. Let's try the 2.8 and see what we get. So second entry. Oh, 2.8. That's it. That matches the 1/16. So there's my answer. So yes, this problem is a little more different than what we typically see here, right? But we just have to work around it. We're not going to do logarithms in this course, so we're not going to take the log of both sides to try to solve this exponent, but just trying to use the numbers that we are given here and kind of by process of elimination, see which one works the best.